So this is 5.6, number 49, substitution. That sign, because it's in the squared, seems like the best candidate to try. Now, one thing about U sub, sometimes it doesn't work and you have to try something else, and it's trial and error. And over time, you get a feel of what's going to work through experience. So we're going to let U be sine theta. If we do that, we take the derivative. So du will be cosine theta with a d theta. So here's what's beautiful. I want cosine theta d theta. There it is. And so I can replace sine with u and cosine theta d theta with du. That is so much prettier than this. So much less cluttered. So this is the important step that confuses a lot of students, and they mess up and they do this all the time and they get it wrong, and you don't want to do this. This d theta tells you something special. It tells you the variable is theta, and that tells you these are thetas. So even though they don't write it, basically these are thetas. Then here, that is telling you u is your variable. Our variables are u, and so these need to be u's. So you cannot place the 0 in pi over 2 right here. You can't do that because it has to be u's. So you need to use your u equation to calculate u. So when theta is 0, the bottom one, u will be sine 0, but sine 0 is 0. So now we can put a 0 there. But when theta is pi over 2, the top value, u will be sine pi over 2, which is 1. So the top becomes 1. Now, this is the important thing. This is equivalent to this. They give you the exact same answer. This gives you the net area, right? That is net area. This will give you a net area of a different function, but it's exactly the same as that. You got to realize they're equivalent. So if someone calculated this on their calculator and someone put this on your calculator, you would get the exact same answer, okay? So what does this all mean? I take the antiderivative, I add 1 to the power and divide by that. And the fundamental theorem says I plug in 1 on top. Then I plug in 0 on top and I subtract them. And I get the answer of 1/3. Done. That's it. Now, here's what some people do sometimes. And it drives me nuts because you're just creating extra work. I don't know why you're creating extra work. They will say, okay, now that I'm here, I'm going to replace that with x. What was x? X is, or u, excuse me, replace it with u. U was sine theta. So they'll go back to sine theta. But then like, oh no, that's theta. I got to change these back into thetas because they're u's. So they go back to the original 0 and pi over 2. And then plug those in. So they're going to get sine pi over 2 cubed over 3 minus, and then they're going to plug in 0 here, and they're going to get sine 0 cubed over 3. And they'll say, oh, sine pi over 2, that's 1. I got that. 1 cubed over 3. And sine of 0, oh, that's 0. 0 over 3. And they get the same answer. But why? Why are you doing all this extra work? You don't need to. Stick with that. Because you don't need to go back to your original variable. Because you're finding net area. Now, in the previous problems, we went back to the original variable because we're finding the antiderivative, okay? But now we're not finding the antiderivative. We're just finding the net area, which is a number, so you don't have to change your variables back.